Let's discuss operations with vectors. Here we have two vectors, vector u and vector v. Vector u is position vector, as you can see, so with the pointy brackets, so 3 down 2. This is my first vector, okay, and then vector, that's vector u. Vector v is left 1, up 4. 3, 4. Okay, here it is. I'm trying to draw a straighter line, so there we go. Okay, so here we have u, here we have v. Here's the interesting thing about vectors, and that is location doesn't matter, so we can pick them up and move them, okay? So if I picked up v and I moved it, it is now there, okay? So what happens now if I'm taking vector u and then I'm doing vector v behind it? The result is this one right here. Let's make it red. We started here, ended here. The red is the end result. So vector u plus vector v is equal to, looks like 2, 2 as a position vector. Now, we wouldn't have to have graphed it. We could have added them by hand. 3, -2 as a position vector. We're adding it to the position vector -1, 4. Now, you can only do this if they are position vectors. And if we're adding it, it will become 2, 2, which is what we got. Now, when you subtract, two different ways to do it. One, vector u minus vector v. First way is when you were doing vector 1 and then vector v, let's go super small. This one, the blue vector, vector v, when it's negative, it goes the opposite direction. So it's going to go one to the right and down 4. So this was our vector u, and then this is our vector v. And in the end, we start here and here. Okay, so what is the red one? Well, it is 1, 2, 3, 4 to the right and down 6. So I'm thinking it's probably going to be 4, 6, but let's confirm it mathematically. We have 3, -2 as a position vector, and we are going to subtract -1, 4. Well, when you distribute, you end up with 3 plus 1 and -2 minus 4. Oh, and I didn't put the negative on the 6, so that's my error there. And there is that vector. Okay? Scalar multiplication is basically just magnifying the vector by a non-zero real number. So when we magnify by a scalar, we have this non-zero real number, okay? Well, you could even multiply by 0, but multiplying by 0 results in the 0 vector. Okay, so we're not going to multiply by 0 because that one's too easy. We're going to multiply by other things. So here they're asking us to say, hey, magnify vector v by 3. Well, this is just 3 times vector v. In other words, 9, 3 will be the resulting vector. Okay, now if I want to do 1/2 vector v, that is 1/2 times 3, 1. In other words, that is 3/2, comma, 1/2, like so. Next, we already subtracted vectors, and we distributed the negative sign or the minus sign, right? So having the negative vector is going in the opposite direction. So a negative vector is the same as a -1 times the vector. So a negative v is like -1 times vector v, which would be -3, -1. Okay? All right. Let's go to the next example here. Here it's saying calculate vector w. It is 3 times the magnitude of u plus 2 times the magnitude of v. So w is going to be 3 times vector 3, negative 2, plus 2 times vector negative 1, 4, which means it's going to be vector 9, negative 6, plus vector negative 2, 8, resulting in vector 7, 2.